Hello, this is Lab 4, the oscillation lab for physics, and I'm Wendell Akers. So, for the introduction, the principles, we're going to be talking about force, gravity, potential energy, kinetic energy, and constant velocity. In my code, you can see, in my code, you can see how when computing the system's energies, you can see how all of those come into play in actually calculating the total system energy and kinetic energy and potential energy. So comparing the predicted motion and observed motion, the predicted model has a longer period compared to the actual experiment and a different ending position for both x and y axis. So yeah, where it's very close, but it's not exactly perfect to the model. And is the energy principle satisfied? Yeah, it's satisfied because on the graph, the change in energy, or the total energy, is zero. So that means that the entire energy wasn't created or destroyed in the system. So it applies to this, the energy principle. And the estimates of oscillation periods. So I did this by counting the periods, so 1, 2, and then using the time posted over here to compute the time for each period. So for x, it was 1.805 seconds, and for y, it was 2.137 seconds. So this means that they're very different. So it would take longer for the mass to oscillate in the y direction, so like up and down, than compared to the x direction, back and forth. And yeah.